Running AI locally sounds almost too good to be true. No monthly subscription, no API bill, no rate limits, no sending your private data to somebody else's server. Just download a model, run it on your own computer, and suddenly you have your own private version of ChatGPT. And technically that is true, but it leaves out almost everything that actually matters, because the difference between downloading a local model and running a genuinely useful AI system locally can be enormous. Your GPU matters, your VRAM matters, your system RAM matters, the size of the model matters, the context window matters. And sometimes a 3,000 pounds computer can still feel dramatically worse than an AI service costing $20 a month. So in this video, we're going to look at what you actually need to run AI locally, what kind of models different computers can handle, whether you need a GPU, why Macs are surprisingly good at this, where Windows PCs still win, how much it actually costs, and most importantly, when running local AI makes sense and when it really doesn't. When you use something like ChatGPT, Claude, or Gemini, the model itself is running inside a data center. Your computer is essentially just sending requests to somebody else's hardware. Running locally flips that around. You download the model weights onto your own machine and your own hardware performs the inference. That means your prompts can stay on your computer. You can run without an internet connection. You can expose the model through a local API, and once you own the hardware, you're not paying per token every time you use it. Tools like Ollama and LM Studio have made this dramatically easier. You no longer need to understand machine learning infrastructure just to get started. You can install an application, download something like Qwen, Gemma, DeepSeek, or GPT-OS, and start chatting. The problem is that model files are huge, and this is where local AI gets complicated. Most people assume local AI is mainly about how fast your processor is. But one of the most important limitations is actually much simpler. Can the model fit into memory? A language model contains billions of parameters. A 7 billion parameter model literally contains roughly 7 billion learned values. Store every one of those values at high precision and the memory requirement becomes enormous. So local models are usually quantized. Quantization basically stores those numbers using fewer bits. Instead of keeping every parameter at 16 bits, you might compress it down to 8, 5, or 4. That dramatically reduces memory usage. And it's one of the main reasons ordinary computers can run these models at all. As a rough example, Ollama historically estimated that a 7 billion parameter model might need around 8 gigabytes of memory, a 13 billion model around 16, and a 70 billion model around 64 gigabytes. Quantization and newer architectures can change those numbers significantly, but the basic rule remains: larger model equals more memory, and memory is often your first hard limit. On a normal Windows gaming PC, you actually have two important pools of memory: system RAM and GPU VRAM. If you have an NVIDIA graphics card with 12 gigabytes of VRAM, that 12 gigabytes is completely separate from the 32 gigabytes of RAM installed on your motherboard. For local AI, VRAM is extremely valuable because the GPU can access it at very high bandwidth. Ideally, you want as much of the model as possible sitting directly in VRAM. If the entire model fits, great. If it doesn't, software like llama.cpp can split the workload. Part of the model can run on the GPU while the rest stays in system memory and runs through the CPU. That means exceeding your VRAM limit doesn't necessarily mean the model won't run. It usually means it gets slower, sometimes much slower. This creates one of the weirdest situations in local AI. A gaming GPU can be extraordinarily powerful, but still struggle with a large language model simply because it doesn't have enough VRAM. NVIDIA's RTX 5090, for example, has 32 gigabytes of GDDR7 memory. That is enormous for a consumer graphics card, but 32 gigabytes still isn't enough to hold every large model at useful quantization levels and context sizes. Local AI can consume memory incredibly quickly. Yes, absolutely. You can run local AI entirely on a CPU, and this surprises a lot of people. Projects like llama.cpp are specifically designed to make CPU inference practical. If you have enough RAM, you may be able to load models far larger than your GPU could hold. So someone with 64 gigabytes of normal RAM and no powerful graphics card can still run surprisingly capable models. The downside is speed. Modern GPUs are extremely good at the kind of parallel maths language models require. CPUs are much less specialized for it. A small model can still feel perfectly usable on a modern CPU, but as model size increases, the difference becomes painful. You ask a question and wait, the model begins answering. But instead of producing text faster than you can read it, you watch each token slowly appear. For experimentation, private document analysis, occasional queries, or background processing CPU inference can make complete sense. For coding agents, fast interactive chat, or anything you're going to use for hours every day, you probably want acceleration. Apple Silicon changes the equation. A Mac doesn't separate system RAM and GPU VRAM in quite the same way as a conventional PC. Apple uses unified memory. the CPU and GPU can access the same pool. So a Mac with 64 gigabytes of unified memory potentially gives the GPU access to a much larger memory pool than a typical gaming graphics card. And that is incredibly useful for language models. This is why people sometimes buy high-memory Mac Studios specifically for local AI. Apple's older M2 Ultra Mac Studio could already be configured with up to 192 gigabytes of unified memory. That allows you to load models that simply would not fit onto most consumer GPUs, and Apple is continuing to push local AI heavily through MLX. At WWDC 2026, Apple was openly demonstrating local agentic AI workflows running through MLX, including coding agents and even multi-Mac distributed inference. But there is an important distinction. Being able to fit a huge model doesn't automatically mean you can run it incredibly quickly. Memory capacity and compute performance are different problems. A large memory Mac can be excellent when the main limitation is fitting a model. A high-end NVIDIA GPU can still be extremely attractive when raw inference performance and software compatibility are the priority. So, which is better? It depends on what you want. If you're building a dedicated AI workstation and want maximum flexibility, a PC gives you options. You can choose the CPU, add large amounts of normal RAM, upgrade the GPU later, run multiple GPUs. Use NVIDIA CUDA, experiment with AMD hardware, and replace individual components instead of buying an entirely new machine. NVIDIA still has a major advantage because so much machine learning software is built around CUDA. That doesn't mean AMD can't run local models. It can. The Radeon 7900X TX, for example, has 24 gigabytes of VRAM, and llama.cpp supports AMD acceleration through HIP and ROCm, but NVIDIA generally remains the safer choice if you want the broadest compatibility across AI software. Macs offer something different. Very large unified memory configurations, excellent power efficiency, simple hardware, and strong support from tools like MLX, Llama, CPP, Ollama, and LM Studio. If the goal is, I want one quiet machine on my desk that can load very large quantized models, a high-memory Mac can make a surprising amount of sense. If the goal is I want to experiment with every CUDA-based AI project on GitHub, the PC is usually the easier choice. Hey, don't forget to like and subscribe for more like this. Now, back to the video. Here is where people massively overcomplicate things. You do not need a 5,000-pound computer to start running local AI. LM Studio currently recommends 16 gigabytes of RAM for both Apple Silicon Macs and Windows systems. On Windows, it recommends at least 4 gigabytes of dedicated VRAM. That doesn't mean 4 gigabytes is ideal. It means you can start with 8 to 16 gigabytes of usable memory. You're mostly looking at smaller models, and smaller models have become surprisingly capable for basic writing summarization, classification, simple coding, or extracting information from documents. You may not need anything huge. Move into the 16 to 32 gigabyte range and your options become much more interesting. You can run larger models or better quantizations and use larger context windows. At 64 gigabytes and above, you begin entering territory where genuinely large models become practical, and once you get into machines with 128 gigabytes or more, you can experiment with models that would require extremely expensive GPU setups elsewhere. But there is a trap here. The model itself is not the only thing consuming memory. Everyone loves huge context windows, 64,000 tokens, 100,000, maybe more, but context is not free. As your active context grows, additional memory is required for what's commonly called a KV cache. So you can have a model that appears to fit perfectly, then increase the context window, and suddenly it no longer fits. Ollama gives a very practical example. One of its recommended local coding models, GLM 4.7 Flash, requires roughly 23 gigabytes of VRAM when configured with a 64,000 token context window. That is already beyond the capacity of most consumer GPUs. And coding agents benefit heavily from large context because they may need to understand an entire repository tool, outputs previous action, and long conversations. So when somebody tells you this model runs in 12 gigabytes, always ask, at what quantization, at what context, and how much of it is actually running on the GPU. Those details matter enormously. This is probably the biggest misconception. You download a highly rated open model, run it locally, and expect Claude or ChatGPT. Sometimes it is shockingly close, especially on straightforward tasks. But there are still important differences. The very best cloud models have access to enormous amounts of compute. Providers can serve models far larger than anything you could reasonably keep under your desk. They can run sophisticated reasoning systems, huge context windows, tool infrastructure, search code, execution, memory, voice, images, and increasingly entire agent platforms. A local model might be free to query, but that does not mean it gives you the same product. This becomes especially obvious with agents. A small local model might write decent code, but ask it to autonomously navigate a repository for 40 minutes. Use tools, debug failures, remember the plan, and make good decisions repeatedly, and the gap becomes much more noticeable. Ollama itself now supports launching coding tools such as Claude Code, OpenCode, and Codex-style workflows against local models, but even Ollama notes that coding tools work best with large context windows and offers cloud versions when local hardware struggles. That tells you something. Local AI is extremely capable, but local and cloud are increasingly becoming complementary rather than direct replacements. Local AI is often described as free. It isn't. The software might be free, the model might be free, but hardware isn't. An RTX 5090 has 32 gigabytes of VRAM. A Radeon 7900 XTX has 24. High memory max can cost thousands, then there's electricity. Storage, a large model collection, can consume hundreds of gigabytes very quickly, and there's the opportunity cost of dealing with all of this yourself, downloading models, testing quantizations, figuring out why GPU acceleration isn't working, changing context sizes, updating runtimes, dealing with incompatible libraries. Meanwhile, you can subscribe to Claude, ChatGPT, or another cloud service, open a browser, and start working. So if your only objective is, I want access to the best AI for the lowest upfront cost, buying thousands of pounds of hardware is difficult to justify. The economics become more interesting if you use AI constantly, or you need complete privacy, or you process very large volumes, or you're building something that would otherwise generate substantial API fees, or you simply want complete control. And this is where local AI becomes genuinely different. Privacy. Once you have downloaded a model, tools such as LM Studio can operate entirely offline. Your prompts don't need to leave the machine. Your documents don't need to leave the machine. You can even expose an OpenAI compatible API entirely on your local network. That matters enormously for sensitive data. Private source code, business documents, contracts, research, customer information, personal notes. There are entire categories of information you may simply not want to upload to an external AI provider. Local AI also means nobody can suddenly change your rate limit, nobody can remove the model, nobody can alter the pricing, and nobody needs to give you permission to build on top of it. You own the machine, you control the model. That is fundamentally different from renting intelligence through an API. The other reason local AI is becoming more interesting is competition. This is no longer just Meta releasing Llama and everyone else following behind. You now have major open and weight model families from companies and research groups around the world. Qwen, Llama, DeepSeek, GPT-OS, GLM, and many others tools like LM Studio and Ollama make switching between them almost trivial. You can download multiple models, run the exact same task, and decide which one actually works best for you. One model might be better at coding, another might be faster, another might fit into half the memory, another might be better at reasoning, and that competition creates something. Cloud AI doesn't really give you choice at the model level. You aren't choosing an app, you're choosing the intelligence running underneath it. So what is the truth about running local AI? It's both easier and harder than people make it sound. Yes, you can download Ollama or LM Studio today and run an AI model on a normal computer. You do not necessarily need a GPU, you do not need a giant server, and you definitely do not need to spend thousands just to experiment. But if you want large models, long context windows, fast inference, and serious agentic workflows, hardware starts mattering very quickly. VRAM matters, RAM matters, memory bandwidth matters, quantization matters, context matters, and the model you can technically load is not necessarily the model you'll actually enjoy using. A modest computer can run impressive AI, a powerful gaming PC can run much more, a high memory Mac can fit surprisingly enormous models, and a dedicated workstation can become your own private AI server. But none of those automatically replaces the best cloud systems, at least not yet. The real advantage of local AI isn't simply that it's free, it's control, your hardware, your data, your model, your limits. And as open models continue improving, the question may slowly change. Today we ask, can my computer run AI? Soon the more interesting question might be, how much AI do I actually need the cloud for?